So the next thing is the second fundamental theorem of calculus that I feel like the workbook kind of makes more difficult than it actually is. Essentially, let's kind of go through this a little bit. Suppose you're asked to find the integral from 1 to x of t squared minus 4t plus 1 dt. This is similar to what we did with the accumulation function, but remember with the accumulation function, this was 0, right? So this is going to end up being for any value below as long as you have a variable on the top, okay? So they want us to use the fundamental theorem of calculus to find the integral of that. Okay, well remember the fundamental theorem of calculus just says that you've got the integral from a to b of some function equals the integral evaluated at b minus the integral evaluated at a. Okay, so we're just going to integrate this like normal. So if I do that, this is what, 1/3 t to the third minus 2t squared plus t from 1 to x. Okay, well if I plug in the x, because that's what I do first, I'm going to get 1/3 x to the third minus 2x squared plus x, right? Minus this whole thing with 1 plugged in. So minus 1/3 minus 2 plus 1. And I could simplify that and figure out what that is, but I'm not going to need to for what we're using it for, okay? So this is what I would get if I integrated this function, okay? Now, if I took the derivative of this function that I just got, so the derivative of this, 1/3 x cubed, would be x squared minus 4x plus 1. And then all of this would go to 0 because the derivative of constants goes to 0. So this answer, the derivative of my integral, is literally this same function, but with the x's instead of t's. Okay, so the basic result, the basic thing that happened is the integrals and derivatives cancel out, right? Because they're inverses. But notice that the variable changed. It went from the t's of this to the x's of that when I took the derivative because they would cancel. But notice that this 1 had absolutely no effect because this 1 affects the constant term. And when I took the derivative, the constant term goes away. So it's not going to have any effect at all on my derivative of my integral. So it doesn't matter if this number is 1, 7, 30. It doesn't matter what it is. You can ignore it. All that we care about is this top number when we're talking about in terms of integrals with variables as the boundaries. Okay, so that's what your second fundamental theorem of calculus is going to say. The derivative of your integral is literally just the function with the x plugged in, assuming it's just an x. So it's the function with the x plugged in as long as this is just an x. If it's not, if it's anything, so it's u, right? Then the derivative of the integral of this function, no matter what a is, we don't care, with anything up at the top, is the function with that plugged in times the derivative of that, okay? So this is fu u prime, all right? So it's a weird thing to look at, but it's really easy, and they ask you about it a couple of times. So we don't care what this a is, but this u, you plug it into the function. Anywhere you see that t, you're going to plug in the u, and then you take the derivative of it and multiply it times that, okay? So let's take a look at this example. So we need the derivative of the integral. Notice it's just an x again. So since it's just an x, it follows this formula. So we don't even really need the derivative. I mean, the derivative is 1, so it's the same. So literally, the derivative of the integral from 1 to x of this function is this same function, but with x instead of t. And I'm done. Okay? These are really, really easy. Take a look at b. What's different about b? Well, this one, I have my variable on the bottom, and I have my coefficient on the, not my coefficient, my constant term on the top. Well, these formulas for the second fundamental theorem of calculus have to have the variable on the top. So I've got to flip this guy over, but we know how to do that. It literally just changes the sign, right? So negative of d dx from 3 to x t sine t dt. So it just flips the guy over, right? Which is totally fine. So then when I plug this x in, I plug the x in for that t. I plug the x in for that t. And I'm done. Okay? So we negate it because it's got to have the variable on the top. We don't care what that number is, but it can't be on the top. And then I just plug the x's in because it's just x. Okay? Now let's look at c. So c, it's not just x, it's x squared, right? So this one's going to have to be the u. So we're going to plug it in and then multiply it by its derivative. Okay? So again, I don't care that this is pi over 2. I'm going to plug that in. And then multiply this by the derivative of that. Well, the derivative of x squared is 2x. Okay? And that's all there is to the second fundamental theorem of calculus. It just says if you have an integral that you're taking the derivative of, your constant terms are going to end up canceling out. So if you've got a variable in the top of your boundary, so to any x in the interval, all you've got to do is plug in the x and that's it. Okay, so hopefully you'll be able to finish the homework tonight. If not, let me know and we'll answer some questions tomorrow in class and then move on to area between two curves. So hopefully this made some sense and good luck with your assignment.